Okay, so there is one more matrix operation that we didn't do in section 2.1, and that is the inverse of a matrix, and it's so involved that it got its own section here. So first off, let's try to talk about the definition here. The inverse of a matrix A is the matrix which we're going to denote by A to the negative 1 power. It is a separate matrix, but it's related to A, so we call it that. Is the matrix that satisfies A times A inverse equals the identity equals A inverse times A. And I'll just remind you what the identity is. There's ones for different sizes. For example, the 2x2 matrices, it's that. For 3x3 matrices, it is this. Basically, that's what we were trying to go for when we did our reduced row echelon form. We wanted it to look like that when we were trying to find our answers. So that was what identity is. So the idea is, if we can multiply A times some other matrix and always get this, and if it doesn't matter which way we multiply it, that is called the inverse. First thing I want to point out is the fact is that not all matrices have an inverse. So some do and some do not. The matrices with no inverse are called singular. Those are going to be ones we don't really want to deal with if we can avoid it, but we can't always avoid it. Okay, so let's talk about how we find the inverse first. Okay, so if we want to find the inverse, then we start by the following. Let's say I want to find the inverse of A is 1, 2, 3, 4. What we're going to do is we're going to create a bigger matrix, kind of like an augmented matrix. But instead of just adding over the column of the right-hand side we're going to put the whole identity matrix right here. So what we're doing is we're creating an augmented matrix where you put your matrix A, and next to it you put the identity matrix. Then what we're going to do is we're going to do row operations. So I'm going to try to get us into reduced row echelon form. And so I would do -3 row 1 plus row 2 goes to row 2. And I'd have 0, -2, -3, 1. And then I would go ahead and divide by -2 on row 2. And I would get this. And then the last thing I want to do is I want to clear out that 2 in row 1. And so let's see here. -2 times 3 halves is -3 plus 1 is -2. -2 times -1/2 is +1 plus 0 is 1. And so when you get it into reduced row echelon form, at least if you can get it in reduced row echelon form, then what your answer is going to look like is you're going to have the identity on the left side, and the right side is going to be A inverse. So that means A inverse here is going to be -2, 1, 3 halves, and -1/2. Okay. Now, as you can see, this was kind of a lot of work. This was only a 2x2 matrix. If we had a bigger matrix, it would be even more work. Say a 5x5 would take you, I don't know, 20 minutes or something maybe, depending on your skill with the row operations. It's a very long process here. There is a shortcut, but it only works for 2x2 matrices. And so if you have the matrix A, B, C, D, and you want to find the inverse, you are going to switch the diagonal elements. You're going to take the opposites of the off-diagonal elements, and then you're going to divide the whole thing by AD minus BC. Now some of you may recognize that AD minus BC, that is the determinant of the matrix. And so if we try this on this one here, 1, 2, 3, 4, it'd be 1 over 4 minus 6 is negative 2. Then I switch the identity, switch the diagonal, 4, 1. I don't switch these, but I put them negative. And then if I divide that here, I get negative 2, 1, 3 halves, and negative 1 half, which is the same answer I got up here. Now again, this only works on 2 by 2 matrices. Does not work otherwise. But the nice thing is first off, you guys know how to do reduced row echelon form on your calculator. And secondly, you can even on your calculator get your matrix typed in there and hit the inverse key, the -1 power key, and it will actually give you the inverse anyways. So finding the inverse isn't going to be too hard for us, I hope. But we still need to talk about what's going on with it. Okay, so we'll continue on.